we'll go ahead and get started here, just because I'm afraid mine might go over a little bit if I don't start now. Okay. So, hope everyone's at the right workshop that you guys are expecting. Today we're going to go over some debugging practices, as well as I want to talk about a tool that Team 930 used this year that was the first time for us, and we found a lot of use out of it, which is the Advantage Kit and Scope. Keep in mind that there's going to be some features in the Advantage Kit and Scope that I will not talk about, because hopefully you guys saw some of that in our simulation workshop. And if not, if we have some extra time, I can show you guys a few extra things after the presentation. So a little introduction. I'm going to avoid you guys the introduction of Team 930 because I'm assuming you all have heard it so many times so far up to this point. But a little bit about myself. My name is Matthew Cook. I am one of the programming mentors for Team 930. I have been on the team now, oh gosh, it's getting almost 6 years. I think, yeah, 6 years. It's been great. I have held workshops both for WCTC as well as our MROC, and then I've also been helping out a little bit outside of our team with some of the things that we do here in Wisconsin. So I'm very familiar with FIRST as well as what we do here in Wisconsin. And a little bit of background about my background outside of FIRST. I have been a software engineer for about 7 years. I deal with application level programming, as well as I have about 3 years of experience around testing, as well as managing hardware racks around testing, things very much that you guys use on your robots today. One of those things I've actually helped develop, which was years ago now, which is the Rio that you guys do use on your robot. I have some experience around that as well. So a little bit of background about me. So what are we going to talk about today? So again, I want to make sure that you all have a clear understanding of what it means to actually debug your code. I want to teach you guys some practices and tools that you can use to actually improve your processes around debugging. Things like logging. I want to show you a little bit about some of the things that FIRST provides you guys that you can use to help you solve problems, whether that's on the field or during your build season, like the driver station. And then I want to go into a few practices that you will find that you will use in your career outside of FIRST if you decide to go in programming, things like debugging, as well as some testing practices that you might or might not use while you're here or participating into the FIRST community, but you will, as you go into the field of programming, you will definitely use. And then we'll talk about this really cool tool that we started using, which is the Advantage Kit and Scope. Hopefully, I can encourage you guys to at least try it this off season. I promise you it will do worlds for you guys in being successful. And then we'll just do some reviewing, wrapping up, and then I'll give you guys some time to ask me some questions. Okay? So that's kind of what we're going to be doing here today. So first things first, can anyone give me their best definition of what is debugging? Yeah.
Debugging your code is going through and finding errors, things that can both help organize your code, get rid of things that could cause issues later, and things that are causing issues.
That's actually a pretty good definition. I would call it a process, and I want to make sure that I make a disclaimer here. There are hundreds of ways that you can go about debugging your code, and those ways that you use were very dependent on the applications that you guys are working on, and it can even be the environment in which your applications are running can really steer the type of debugging processes you take. So it's important because you guys are inevitably going to find problems in your code, right? I don't think anyone here can tell me that you wrote 100% working code the first time and you never had any problems with it. Or if you have, I promise you, you will come across problems. So I want to teach you some skills around that and hopefully help you guys in the future. But in order to actually debug, there's one important thing we should understand first. What are bugs? Can someone else give me their best definition of a bug? Sure.
Either an insect or a problem within you.
I like that, insect. But yes, it is a problem. It can be a problem outside your code. Just want to make sure you understand that. It can be a problem both in the hardware side of the world as well as your software side. We will focus on the software side of things just because that's the focus here today. But I just want to make sure that you guys have a clear understanding, or I should say a clear expectation of how you can define your bugs. And so that's what I want to touch base here real quick. I found this picture online. I thought it was a very cool idea of how you can define your bugs. Because if you can do a good job up front defining what your bugs are, it can actually help you figure out where your bugs are actually derived from. And so there's 3 kind of areas that you want to focus on when you're thinking about your bugs. Scope. Scope is the area in which your bug resides. So if you think about code and you think about functions, open and close brackets define a scope, right, in your code. Anything that happens in that scope is derived inside that scope. Same concept with bugs. Whenever you look at your robot and something goes bad, let's say your arm starts going crazy on you. You got to think about where in your code would that reside, right? If something bad happens with your arm, where should you not look to go find that problem? Drivetrain, yes, exactly. Yep, exactly. So it's important to define the areas in which those bugs reside before you even go looking for them. It just gets you there faster. On top of that, effect. So this is a little tricky to explain to you guys in a broad sense, because in your world, the effect is something bad happened on your robot, right? But in the outside world, it can be more than that. It can be more than the application. You can affect the environment in which your product runs in. You can even affect the users of your product depending on what it is. So for like me, where I work on MR scanners, and we do processing on images. If our product doesn't work properly, we can actually cause doctors to kill people. So it's important to understand how your bugs can affect others. And then on top of that, severity. So in your guys' world, you have a limited amount of time to actually fix bugs, right? And so you might find, n number of bugs. You might have 10 bugs. You have to be able to prioritize what is important, what is really bad, and what is okay. Maybe it's somewhat bad, but it's okay to be there, and then just manage your time around those bugs. So just things to think about as you're going about trying to solve problems in your code, okay? So tools. What are some ways that we can go about trying to solve or try to fix bugs? And I kind of said in my intro, I just want to see who was paying attention. Unit tests, yep. What else? What other ways can we test our code or debug our code? Breakpoints, yep. Do you know what that's correlated with? Do you know the application that you use to actually do that? Okay, well, we'll go over that. That's fine. Anything else? Integration testing, yep. So running your stuff on your robot. There was one more that I had on there. Do you guys remember seeing it? Logging, yep. So those are probably going to be the 4 most useful and the ready available for all you guys to actually debug your code. And so I just want to talk a little bit about each one of these. Make sure you guys understand some positives and negatives around different things you can do to do these 4 types of debugging, and then hopefully it'll give you guys some skills around debugging and do a little bit better job of figuring out problems. So the first thing, logging. What is logging? And no, it's not moving logs. I just like that picture because, logging. Can anyone give me their best definition of what logging is?
Collecting data from events or outside sources.
Man, you almost hit that right on the definition. That's actually pretty good. Yes. So it is logging events. It's really more of recording events as they happen in your code, okay? This type of debugging takes a little bit more of a forward thinking. As you write your code, you got to think about what are some important information that you need to log for later evaluation, or where could problems arise in your code, and make sure you're logging those areas or those issues beforehand. So this is more of a proactive way of debugging your code. It's not really a reactive way, because in order to be effective with using something like this, you have to have put the logs in there yourself. So again, think about what are some important information and then log it for later use. There are 3 different ways that you guys will probably, well, I should say the first 2 are probably ways you're doing it today. So the common one is print statements, and then there's actual tools or libraries that are either coming pre-installed with your WPI lib, or there's also third-party ones you can download that allow you to actually log your code and has some really nice features around it. We'll talk very briefly about these 2 things in the next couple slides. And then the last one, which is actually a form of logging, I will touch base a little bit more detail towards the end of the presentation. So let's talk about the first one, print statements. Show of hands who all have used print statements in your code. I expect almost all of you at this point. Yep, exactly. Print statements, why everyone uses them? Well, they're easy to use, right? There's not a lot of configuration, not a lot of setup, and you can put them on the fly and you can get a very quick response from those print statements. It is a form of logging because it does technically log it to your execution terminal. So when you guys run your code through your WPI lib, it actually executes your code through an execution terminal. That's your log that pops up when you actually run your code. The reason why they do that is they create a channel between that terminal and your robot that's running, and that's how you capture all your print statements from the robot, okay? I have them here, but, you know, does anyone understand some of the limitations of using a terminal for logging? Small output window, yes. You can make it bigger, right? You can scale it if you really want to. What else? Does anyone understand how a terminal works?
I guess another issue might be it's going to be hard to log stuff while the robot's actually running.
So it might be hard to find, right? Because there might be all kinds of information thrown. It's also very not color-coded or clean. You can't really affect a whole lot of how it looks. But the other big problem with terminals is they have a limited character, a character limit in which how much they can print on the screen. You can change that, but sometimes it's tricky depending on the terminal and also your operating system. Your operating system can define your maximum characters. So if you have minimum characters, the likelihood that you're going to get all the information you log is very low. You will lose data if you rely this heavily as your logging platform. And then the other big problem that I want you guys to think about is when you're using things like print statements, it's very CPU intensive, especially if you're doing a lot of print statements one after the other. In fact, we've had issues on 930 with this where we have so many print statements, our code actually lags and our process runs really slow. And so in order to speed up your process if you're using print statements, what's the only way to fix it with a print statement? If you have too many. Nope. Remove them, right? And so finding them can be a pain, especially if you put print statements everywhere. So not only is it bad for your hardware, it's time consuming and it's hard to manage, okay? Go ahead.
Well, your loss of data is a little bit bigger than you can't just print it all. It's also, the program ends, the data's gone.
Yep,
You don't
that's
have
true.
it,
Yep.
If you actually log it, you have it for comparison between runs.
Yep, exactly. Yep. So the point of talking about print statements is I'm pretty sure most of you probably still use print statements. I want to encourage you to get away from it. And we at 930 are still trying to get away from it as much as possible. And so the alternative to print statements, like he just suggested, is logging it. So there's a couple different applications out there. The two that you guys are going to have readily available that comes pre-installed alongside your Visual Studio Code. You do have Java logging, so the Java logger, as well as the WPI lib actually has a decent logger built into it, okay? Both of these have some different configuration capabilities. I'm not going to go into detail on that. You can easily go look that up online. It's very simple, pretty straightforward. But I want you guys to understand why you would use a logger over something like print statements. First and foremost, it has a very nice interface that allows you to guarantee that you're dealing with one instance of your logger versus if you start putting stuff, you can actually, in some cases, you can do some crazy things with print statements where you can make them go to different terminals, and it's kind of fun. But anyways, logging, the interface is pretty easy, as well as there's a couple different things you can configure these to do. One is you can still make it print to the terminal if you really want to. I highly recommend you don't. But you can also tell it to save it to a file. What's the point? Why would we save it to a file? Yep. On top of that, you can tell and define where these files go. So you have some control and management as to where files go as well as the size. And then on top of that, you get all of your data. So when you turn off your robot, you can easily turn it on, go grab those files, and then review them and actually figure out what might help you figure out problems in the future. Now, there are still a couple cons to think about, okay? Disk space. You're saving a file. Yeah, the more files you write, the more disk space you use up. If you actually use up all your disk space, that can cause your robot to actually turn off to protect itself from damage, as well as we've we've come into a problem, depending on how you label your logs, it can be also hard to figure out what's what. So just make sure you're thinking about how you manage your disk space. And then the last thing is this can still be CPU intensive if you don't utilize it right, okay? So for example, the Java logger has a lot of infrastructure around, you can choose what logs print, you can turn on and turn off certain logs, and there's even a really nice interface on both of these to just completely turn them all off with one modification to your code. And it just makes it easy to manage, but if you're not careful, you still can have a CPU utilization problem. So just things to think about, okay? And just to give you a little quick example, so here is logging inside your code, and then if you look here, this is an example of what a log might look like. So it can still be a lot of information, but you get a little bit more control on how this looks and what you're logging versus something like a print statement where you have a bunch of stuff printing to your terminal. All right. So we talked about logging. Let's talk about a form of logging that actually first provides all of you. Does everyone understand, or I'm assuming everyone's used the drive station, right? Everyone's used the drive station? Who all has actually used their logging infrastructure? That's what I was expecting, only a small portion. We have found over the last couple of years that teams actually aren't utilizing this enough because there's just a lot of people don't know about it. So what I want to do is talk a little bit about the driver station and how it logs things for you, and I want to give you a quick little demo of how to actually get to it. So the driver station itself, everyone's probably very familiar with that guy up there. I don't know if you guys can see it, sorry. We'll kind of put it in the middle here. So the driver station is your interface to your robot, right? There's some key information here that you guys should keep in mind that'll help you solve some problems. First and foremost, I don't know if you can see, you can't really see that, can you? No. First and foremost, these three notifications in the middle are probably the most useful, especially for programmers, okay? Your communication, can anyone tell me what that communication indicates? Or I've heard people, and we call it comms. Does that help you guys understand? The light bulb, but go ahead.
Red means no communication.
To what specific?
Robot.
Yep, and what typically do you communicate through?
The radio.
The radio, exactly. So this can give you a quick indication of whether or not you have issues with your radio. It can also, in some cases, if your radio is okay, it can give you some indication there might be a problem with your Rio, but for the most part, it's your radio. What about the robot code? Someone else? What does that indicate?
It means that code has been deployed to the robot.
Yep. So what does that really mean on your code in the code world, though?
In debugging?
Or yeah, what is, if you see all green, what does that mean about your code?
That means that it will run. There's no guarantee that it might
Right.
crash.
So it compiles, right?
Compile.
Yeah, so you have no compile errors. So you know that you've deployed successfully to your robot. It should run, right?
Yeah.
Okay, good. And then, of course, you have the joystick. Everyone knows what that is. That's your control input, and just make sure that it indicates whether or not you have a joystick input. Now, one thing you guys might not use too much of is the error, the status window. And what this does is it actually displays logging from the under the hood logging that it does. I don't know if you guys know this, but a lot of the third-party vendors, actually their integrated libraries directly send logs to this logging. On top of that, WPILib does some nice logging under the hood that you guys don't have to touch that gives you some information around things like your CAN bus. It can give you some information around your radio. I know that I'm missing a bunch. There's a lot. I don't know, is there any that I'm missing that I should state? Nah. There's just a lot. It does a lot for you with very little setup and interaction from you guys. Exceptions, yep. So one of the cool things, however, though, because this is a small window, you don't get very much like the terminal being small and hard to see. First has actually provided a tool. Let's see if it pops up. You just hit the gearbox and you go to File, View File, Log File. Did I not click it? Please work. Come on, there he goes. Okay, so they have a log parser that's built into this tool, and that's what you got here. So this is the log file viewer, and on the left over there, you'll see a list of logs. What's really cool is they automatically timestamp and date every log in the order in which they're written. On top of that, during competition, they will actually go in and put a indicator of whether it was elim 5 or your your qualifier match, and it'll give you the number in which the qualifier match you ran. So it helps you very quickly figure out which log goes to what competition and what match. And when you click on them, you can actually, it will automatically load it into the viewer. There's no loading or picking, you don't have to go to a file load. And it gives you some just high-level detail about the log itself, as well as how to find it if you want to move it. And then it has some really cool debugging tool here, a debugging window here, which is basically it is a, I lost my train of thought. So it gives you a window into viewing exactly everything that is logged. And there's some key ones that you guys want to think about when you're using this. And they're kind of pre-selected on the left here, on the left. So you have things like the RoboRio CPU. Does anyone know what that would mean if you think about the RoboRio CPU?
Like CPU utilization.
Yep. What's the problem if you use 100% of your CPU?
You're going to start slowing
Yep.
processes down because
What can cause that to happen?
per se.
Okay, I just want to make sure that we're reflecting on what I've been talking about up to this point. Yep, so things like print statements and stuff, you'll actually see your CPU utilization go up to 100% if you're not managing that, and so that's a good way to figure out what's wrong. What about the CAN bus? I bet you everyone here knows what the CAN bus is. So CAN percentage, that tells you how much of your CAN is utilizing. What's wrong if you max out your CAN utilization?
Devices are probably talking to each other when they probably shouldn't.
Yep, so that causes delay in response, as well as you can cause exceptions as well. So that's important to understand how you're communicating and how you're getting how much are you telling your motor to move when you might not need to have to communicate to that device as often as you are. And then there's some really useful things about latency and packet loss. So this goes back to communication. You guys, the likelihood that this is going to be a big problem for you is a lot lower than some of those other ones. But if you're doing things like packaging big data points and you're sending them across your radio to the robot or to or from the robot, that can cause latency issues, so delay in response from when you tell the robot to do something versus when it actually does something. So this can give you a good indicator of, do I need to refactor the way I'm moving data from my computer to the robot? So things that you can keep in mind that'll help you. There's a whole plethora of other things. There's different things you can turn on and off. Again, I'm not going to spend too much time on this because there's just a lot, but I highly recommend that you go into the WPLab library or WPLab documentation. They have an entire section on this, and I'm telling you guys, this will save you some time, especially during competition when you don't have a lot of time. It can kind of get you to where you need to be.
One thing to point out is the plots right next to the groups is another way to you can actually get in more granular with
Yep.
the data that's there. So if you really want to look at certain things, you can get more granular with the plots.
Yep, and you can zoom in and zoom out, and you can do all kinds of fun stuff with this. So it's a really good tool. I highly recommend. If you're not using it, use it. All right, so we're going to go back to my slideshow here. So that's what I wanted to touch on logging. So now let's talk about a debugger. So you talked about breakpoints. I don't know who was talking about breakpoints. You were. But breakpoints are always associated with some kind of a debugger. Does anyone know what a debugger is? Sure.
Just a program that you run your code with that allows you to essentially read variables in real time.
Yep.
Allow the code to stop at execution so that way you can sort of see what the state of certain variables are and help you debug your code.
I love the fact that you said it's a program. Not many people know that it's an actual program that you run alongside your code. And typically you have to build a debugged version of your code that provides the injection points for the debugger to actually go in, put the breakpoints in, and allow you to actually pull the information out of the memory. The biggest key around why you would use a debugger, and you will use this in the real world if you decide to go in as a programmer, is you can get access to what's called the call stack. Before we get the call stack, the whole point of the debugger is it gives you this control around breakpoints. So breakpoints are basically points in your code that you want execution to stop. and it gives you some control around stopping your execution. You can do things like step into your code, so if you're at a function call, you can actually tell that code to execute and stop at the first line of code in your function. You can also step out, so if you step into some call, you can then go back to your previous location, and then you can just simply execute line by stepping over every one of your lines. So it allows you to control the execution, and in some debuggers, they actually let you go back to previous executions. You can actually go back up your call stack and go to previous states of your code and actually see how things run out. So there's a lot of control around the debugger. But the biggest thing that is important that probably not many people know how to use, especially you guys as students, is the call stack. The call stack is very powerful in the sense that it shows you the state of your memory at any given point. So you can see things like, how are your variables set up? What is your variable storing? You can even see the execution order of your actual source code and the workflow that your source code is doing. This looks differently from debugger to debugger. There's a couple different ways. It also looks a little differently when you talk about the form of programming that you're using. So whether you're using Java versus C++, C code, Python, the way that they represent this is a little different, but they always, in general sense, display the same information, okay? I can spend hours going through a program and show you guys this, and I, again, don't want to spend too much time in detail, but I encourage you guys to spend some time, take your code that you're running today, put a breakpoint and look through it, and just kind of get a sense of what you're looking at, because it can actually help you solve problems in the future, okay? So that's debugging. So these first two things I talked about really talk about how you as the programmer can interact with your code to figure out what's going on. But what if you want to figure out a problem before it happens? What if you want to try to find a bug before you actually put the robot out in the field? The way you can do that, and I highly doubt that any of you do too much of this, is unit testing. Show of hands, who knows what unit testing is? Okay, cool. Did you learn that from your mentor, or did you learn that from your school? Because I would be very impressed if your school teaches this type of stuff.
It was sort of on my own with the help of
Okay.
the mentor,
Okay. Yeah. So, can someone give me their best guess of what unit testing might be when you think of the word unit? And I want to give you probably know, but I want to give everyone else a chance. Sure. I'll take you.
Choosing an area or a specific part of your code and solely focusing on that rather than the majority of it.
Yeah, that's really good. And then you're testing that, right? And so the idea is you take a portion of your code and you exercise it to the best of your ability and try to catch every corner case that might come about and how your code is executed, okay? The problem with unit testing is very time consuming, so it takes a little bit of a forward thought and how you design your code, because you have to write your code in such a way that you can take those individual components and actually test it. And so typically you won't see first teams using unit testing. I have tried teaching it to my team. In the limited amount of time we have, it's just a challenge to get people to think in the way that you need to actually utilize this. But I will say this, if you haven't done any of this, I highly recommend that you do try to do some of this on your free time, because in the real world, in the biz, you're going to be expected to do this. And so it's kind of sad that we don't talk about this type of testing so much in high school and even in the first community, because I think it's a skill that if you guys learn it now, it sets you ahead of everyone that you'll compete against coming out of college. So think about this. I do have a little bit of an example here that we'll just, back up. The other problem with unit testing is your environment that you guys get from WPILib is not configured and set up to really do this to the extent that you're going to need. There are hundreds of different tools out there that you can use to do unit testing, and they all have their quirks, they all have their differences, and it's a learning curve a little bit to actually utilize these to their full extent. On top of that, what's the one thing that our programming codes require at all times? What does your code always need in order to function? A robot, right? Do you think trying to push corner cases and put bad values into your code and run that directly on your robot, do you think that's a good thing or a bad thing? Not a good thing, right? Because you're likely to break it, right? So the idea with unit tests is you're supposed to do this outside of your environment, and you're supposed to run it still against hardware, but then test it to the extent. So the way you do that is you use simulators like Mukwonago. You guys probably saw some of the simulation if you sat in our simulation presentation. That's a little different than this. And again, that's the reason why you won't see many teams use stuff like this. There's just a lot to learn and a lot to set up in order to do this. And then just to give you a quick example of how this looks. So for understanding of why you would do it, so about 2 years ago, for our shooter, we made a math class that allows us to put in a position and it will calculate the angle we need and whether or not we can shoot and make the target. We had a bunch of different functionality, underlying function that we created, and we wanted to test that. But we didn't want to do that all on the robot, so we wanted to do that through code. So we actually started using JUnit and actually created unit tests around it. And so for example, for like each one of these are a different test case, and basically all we're doing is we're providing a different position, and then we check to see if that position returns what we expect. And that's the idea. The idea of unit testing is easy, the implementation is the tricky part. Okay? So we won't go too much more about unit testing, but just know that it is there, and I highly recommend you guys look into it. So how about the thing that I know all of you know how to do? Can anyone explain to me how you might do integration testing for the robotics teams?
Put your robot on the field and run it.
Yeah, exactly. Just run your code on the robot and see how it works, right? Why is it called integration testing?
Because it integrates all the units.
Sure. So I don't know how big your guys' teams are, but in the previous years, our team has been somewhere between 10 to 15 students, and every student is designed or put into a sub-team, and each sub-team works on different parts of the robot, right? We don't always think about what's going on those other sub-teams and how our code correlates with other pieces of code. So we test it by putting it all together, running it on the robot, and let's just see what happens, right? That's integration testing. That's why we do it. And the whole point of doing the integration testing is to capture what? Bugs. Yeah, exactly. So that's why it's important to do it. We have a video here of us actually testing stuff. Can you hit the? I guess I can do it. So this was this last year or the year? No, this was year. Was it last year? Yeah. So the first half, you go ahead and hit play. The first half of the year, we decided to go with a catapult, and so we were creating a bunch of different components around the catapult. We had a couple different subsystems, as well as we had the intake, and again, different parts of the team create different components. We did a lot of this integration testing, making sure things worked as they expected, and we had a lot of problems around that catapult, which was kind of a fun challenge for us. We ended up going to a shooter, like, what was that, after the first competition? So testing is important. It gives you a good understanding of where you're at. And whoa, thank you. So that's just a little example of integration testing. All right, so we've talked about 4 different ways you could test. We talked about logging, we talked about the debugger, and we then talked about unit testing and integration testing. What if I could tell you we could combine a couple of those to make a pretty cool tool? Well, we didn't make a pretty cool tool, but there's a tool out there that combines a bunch of these that can make your life a lot easier to test. And that is the Advanced Kit and Scope. So it's this tool, it's a third-party, you can call it a third-party vendor product, but it's designed by Team 6328. They've been in development of it for the last like 5 or 6 years, and I think 2 years ago is when they first did their first initial release, and they've done a lot of improvement over the last couple years. And this last year, we decided to use it. And what it is they have a library that is their own version of essentially the WPILib logger. And they've put in a bunch of functionality and integrations with their GUI side of their tool, which is the Advanced Scope, that allows you to do some really cool things with the logs that they create, okay? The idea here is you integrate their logger into your code, and there's a few setup, and I'll walk over with a demo here in a moment of what that looks like. And then you can essentially call logs wherever you want to log data. And you can actually form the way that you display those data in a very nice little way with their what's the word I'm looking for? Their tagging system, essentially, that allows it to organize this data in a very nice and clean manner in their GUI, so it makes it easy for you to find your data. Because as your logs grow, the harder it is to find data, right? So they have a really nice interface. So what I want to do, so this is the Advantage Kit, and then they have their GUI, which actually allows you to parse it and go into it and dig deep into it, okay? So what I would like to do here today is do a little example of utilizing this tool. I want to encourage you guys to use it, but then also we'll show you one of our logs from a previous competition this last year and why this is such a powerful tool altogether. So give me one moment here. The way that I'm going to give you guys this example, one of the tools that we use, and I encourage everyone to use this if you've never seen one of these. Does anyone know what this is? Actually, I'll have you because you haven't talked yet.
Romy.
It's Romy. What's so important about this little guy?
It uses a simulation basis program that's different from GyroStation
Yep.
to run the program and code into it.
Yep. And what's so cool about this, though, with in regards to our libraries and stuff? You can run the entire WPLib library on this little robot. You can actually run your own code on this robot as long as you reference the right hardware that's on this guy. So we at 930 use this as a training tool. So what I have done over the last couple of years is I've taken an example project, I gut it, and I come up with a lesson plan around it and teach kids how to write command base and do some fun things with it. It's a very powerful tool. I recommend everyone to get it, and I have links at the end of the slides that you guys can go to get these kits. So what I have done here today to help teach this Advantage Kit and Advantage Scope is I've taken the example project of this and I've integrated the Advantage Kit into it. Now, the code that I'm about to show you, I have put it up on a public repo. Again, the link is at the end of the presentation. You guys can go grab it and you guys can get a very simple example of how to do this with very little fluff around it. You don't have to go through someone else's code to figure it, or someone else's project to figure it out. The other thing that I've done really nicely for you guys is you can, let's see here, I've added tags with this info comment around everything that I added, and it will show you exactly what I had to do to get this working in the code, okay? So the first thing that's important to note, on my team I try to keep kids out of the robot.java because that's kind of a templated class that first wants you not to touch too much of to make your robot work as expected, but you do have to make some modifications to your robot.java in order to get this to work. And very simply, you just have to extend the log robot. There is some installation around this. I'm not going into that detail. There's quite a bit of extent instructions on actually downloading and installing their vendor library, but the source code itself is really easy to modify. You just extend this log robot onto your main robot.java. That gives you access to their logger. And then the last thing you have to do, the biggest thing you have to do is there's a set of configuration you have to do through the initialization. So in here you can specify where your logs go. I think there's, I don't know all of the fun things.
There's simulation mode, there's logging, and then there's also a playback mode.
Yeah, so there's different things you can enable and disable to make your logs more informative. And then the only thing you have to do is figure out what you want to log and simply go in and call your logger, very much like you would with a Java logger or the WPL logger, and log your data. So can anyone tell me what I want to log on this little guy if I'm going to do something? And I'll tell you, I'm going to make this guy run 10 inches forward and 10 inches back. I have an automated function for this. Encoder values, good. Can anyone else tell me any others that might be important? Motor speeds, yep. What about, so this thing has a way to determine how far it goes. Wouldn't it might be important to figure out what it thinks it went versus where it actually went? So logging that information might be important. This thing has a gyro. If you're trying to make it turn or face a certain way, you might want to log that, right? Trying to think. This thing is pretty simple. What about your robot? What are some, like your actual competition robot, what are some things you might want to log from that might help you figure out problems in the future?
What commands are running in a given time?
That's a good one, yes. Yep. What else? Anyone else give me an example? What if something bad happens? Where would you want to put a log? we always talk about trying to capture information, but you should think about errors, right? Are you guys doing try catches in all your code anywhere? Where would you put a log if you wanted to catch a problem? In the catch, yeah. What if you have if-else statements, and what's typically, like you have an else statement that defines a bad state, you might want to put a log there, right, to kind of indicate where a problem might be happening, right? So it's important to think about that as you're starting to use stuff like this, okay? The reason why we want to use something like this is because you have a really, really, really nice tool which is called the Advanced Scope. So what I have done, and I should have be connected to the robot, I hope I am. This Romy, yeah, I'm connected. Like what you said, you simulate your code, and the simulation runs directly on the robot instead of just on your on the computer. What I have done is I've taken this example project, and I'm going to put this on the floor so that way I don't hopefully make it knock off the ground. Or actually, we'll just put it here. And I have simply created a little project here. Let me show you guys. You can simulate your robot. It will simulate. Oh yeah, this might take a second. Hopefully. We'll see. I'm doing okay.
Since this Advantage kit extends robot, log robot, you have to make sure that when WPI Lab upgrades, so you do upgrade of that, you upgrade Advantage kit. Because it extends that. If you don't, you could get a sync and hit exception because it's wrapped.
Okay, so hopefully, yeah. So hopefully some of you have seen this in our previous workshop, okay? Again, not going to go through this because we've already gone through this, but what I've done, and you can see the Romy gyro and the built-in accelerated class that comes with pre-installed with the example class. You can see those components there. What I'm basically going to do, and I hope I don't make this thing run off the table because I will. I'll be replacing it for the team. Huh? They should be okay. I'm going to tell it to go, and it's just going to simply try to run forward 10 inches and run back 10 inches. Pretty simple, right? But what if you want to figure out, let's say this thing starts spinning in a circle. What if you want to try to figure out what's going on? Well, you can use this bad boy, and you can connect to it through the simulation. So I'm going to connect to it, and you can see that it's going to start recording stuff. So on this left here, has all of your logs. So basically it generates, or it looks at your logger, and it looks at how you have formed your log statements. So it's important to show you this. So if you guys look here, I have formed my log statements to go into a drivetrain subfolder in the Advanced Scope, and then I've given all of my data a unique identifier. When you do this, it actually organizes that data in the format that you put there. So you can see down in real outputs, here's my drivetrain folder that I've created through that key that I've made, and then all of my things I'm logging, okay? And you can actually put these things right here, and you can actually view it and watch what happens. So I want to show you actually the let me try playing this one more time. So if I disable, so you'll see that I'm logging my PID values. So I have actually put a PID controller on there, and you can start seeing your PID values start mapping out here as the data that you log. There's some cool things you can do with tables and stuff like that, so you can actually just put out all of the information and actually cycle through it through here without having to look at the log. And there's a whole plethora of different other tools that you can use, so you can do some really nice graphs. The simulation one should have showed you guys the odometry one, so you can actually make a 3D version of your robot, and if you are recording the pose 2D or 3D, you can actually make it replay your match later. And then on top of all that, this is me reading the logs as they're being written, which is basically that guy's running, logs are being written. you can also load in a previous version or a previous log from the past. So I wanted to show you that real quick. And these are really the big keys that we wanted to show you here today. So you can come up here to File, Open Log, and I have taken some of our, so here's that Q&E. So I've taken some of our logs. I think I grabbed one from our Wisco competition, and I think I've grabbed one from our Pittsburgh competition, okay? But you can see the E and the Q to represent the match. I'm going to load in this one, which is a elimination match. And you can actually go in, if I go to my odometer tree, so you guys should have seen something like this in the last one, but you can actually go and play back this log, and you can replay what it is that you logged from previous matches. So if you see something bad, you can kind of start digging into your logs to try to help you figure out what the problem is, okay? So there's a lot of tools, a lot of information here. There's a lot of cool things you can do in here that'll help you figure out what's going on. And they've done the team that's created this has done a pretty good job of documenting it. I have put the link at the end of the presentation again, so that if you guys want to go start playing with this on for yourself, I highly recommend it. This has made us very successful this year in figuring out problems on the fly. But that's kind of the high level of what I wanted to cover for the Advantage Scope and Advantage Kit. Okay. So if we go back. All right. So that was the demo that I just gave you guys. So recap. So what did we go over today? Talked about what is debugging. I wanted to give you guys some tools that help you figure out problems in the future. So things like how would you use logging? How might you use a debugger? As well as I talked about a couple ways you guys can be a little bit more proactive in trying to capture errors before you get out in the field. Things like unit testing, as well as how to do, why you would do integration testing. And then finally, I gave you guys a little bit of a demo on a tool that I hope you guys all at least try this off season, which is this Advantage Scope and Kit. It provides a lot of good information. It's a fairly easy to use tool, and it really doesn't take much to get it up and going, and I think it can provide you guys with a lot more information than probably what you're using today. Okay? Again, so if you have any questions, feel free to ask them. This is your guys' chance. No questions?
When you load the logs in like Advantage Scope, can you tie that to like VS Code in the simulator? So you see your robot moving around, right there, that's where something went wrong.
I don't think we've.
Can you get to like if I change this input here, can it
That's a good question.
There's a way in the playback. We haven't used that feature, but it's in the playback way of playing back your log. It's supposed to be able to do it in your code, and you can step through it. We have not used that part this year, but it has that third option of the playback.
I know, was it Jonah? He's a software lead for Mechanical Advantage, or at least he was this year. He had a presentation at Worlds where he was talking about how they log all of the inputs. You can change the code and then re-simulate it with.
Gotcha.
So that's the playback part.
Yeah. Yeah, we don't use that. We
We didn't this year.
yeah, we primarily using this to help capture what's going on the field when we're not able to actually figure out what's going on. And it's really,
I saw him do that, and I'm like, that's really cool.
yeah.
Get it installed and set up first, though.
Yeah, well again, I have,
This'll help.
this will help.
Graduate level.
Yeah, so again, that project, if you guys pull down that project, you can see all of the things I've added in the code. And then I would recommend, I've put the resources here. I would recommend you go, so this is the Chief Delphi post for the Advantage Scope and Kit. They have a link to their documentation. I would go there, and all you gotta do, you can use this project to kind of see how I followed the instructions on exactly what you have to do to the project setup. It's a one-time hassle, but if you get over that hurdle, it just makes a world of a difference in debugging.
The scope can be used actually without even the kit being installed, but it's just in network cables and it has to be used live. The kit has to be installed if you want to save the log file and then be able to load a log file after the fact. And make sure, we found issues that we logged it with Smart Dashboard, but then we forgot to put it in this logger. And then when we go back to look at the log, it's not captured because we didn't do it through Advantage Kit. So
Okay.
you have to watch out for that.
We use this to help capture we've used this to help find CAN issues, voltage issues. We use this to help capture. We actually use this to also PID our drivetrain for autonomous. We've used this to also PID and figure out our issues in deadbands with our arm and manipulator. I mean, this has just made a world of a difference on how quick we can respond to change on that robot. So.
So you guys, when you're developing the software, so like this last year, our biggest problem was building it in time to get it to the software team.
Yep,
So the software team
that's a
was doing
problem.
A lot of writing code going, oh, they said they'd do this, so I think this will work. In our first competition, I think we got the robot for the first time, like, I think it was 3 days before we were gonna load it up and take it.
Oh, we know what that's like.
So there was parts of code where the drive team's like, has anybody tested this? And we're like, no, just run without it.
So I know you
And
probably,
I don't know if you can-
I don't know if you sat through our simulation presentation or not. You did? Okay, so hopefully we talked about the Mecanum 2D and the Mecanum 3D. So that was a new thing we did this year. And one of the things that I'm quite proud of our team is we have gotten to the point where we can simulate like 90% of our robot, even before we get a robot. That really helps us figure out the execution of our code. It helps us figure out if we're at least like 80 or 90% there with our code before we actually get the robot. And it's allowed us to be a little bit more productive when we don't have the robot. This is more of a post-run type of a tool, so you have to either run the simulation or run it on a real robot and get the logs and actually watch it. But this could give you a more visualized version of your simulation to help you see, okay, is it behaving in a sense that I expect? And that's the whole point of this tool. And then the tabling and the way that they can parse the data, because there's just so much data sometimes. It's just hard to get through all that data. This gives you a real nice table, real nice graphing tool that allows you to see that visually. And it's helped us just dramatically this year. So. That was a good question, though. Any other questions before we wrap up for today? Nope. All right. Well, I want to say thank you guys for coming. I want to also wish you all good luck this weekend and hope you guys have fun while you're here. And again, if you have any more questions, you can either stop us while you see us, or you can, we do have, I don't know. Yeah, we do have our Instagram and Facebook, as well as for programming, we do have our Bear Bytes. We have a Discord channel, so if you guys aren't on that, I feel free to stop by our pit and we can get you guys the code to scan to actually join us while you're here. Okay? Awesome. Thanks, guys.